Hello there, cosmic wanderers, and welcome to another mind-bending journey with the weary researcher. I'm absolutely thrilled you found your way here tonight, whether you're settling in after a long day, curled up somewhere cozy, or perhaps lying in bed, gazing up at the stars through your window, wondering about the impossible. Before we embark on what might be the most extraordinary thought experiment of your lifetime, I'd love to know where in the world you're watching from and what time it is in your corner of the universe. There's something very interesting about exploring the limits of cosmic speed while we're all scattered across different time zones, each of us experiencing this very moment at our own unique slice of Earth's rotation. If you find yourself enchanted by these deep dives into the mysteries of physics and the cosmos, I'd be ever so grateful if you gave this video a gentle like and perhaps hit that subscribe button. It helps more curious souls like yourself discover this peaceful corner of YouTube where we can ponder the most profound questions without the rush and chaos of everyday life. Now I should give you a friendly warning before we begin. Tonight's exploration might be so fascinating that it keeps you awake longer than you intended, your mind spinning with possibilities that challenge everything you think you know about reality. But if that happens, at least you'll drift off to sleep with your consciousness expanded and your sense of wonder thoroughly awakened. So take a deep breath, let your shoulders relax, and prepare to have your understanding of space, time, and the very fabric of reality completely transformed. Tonight we're asking one of the most tantalizing questions in all of physics. What would really happen if you traveled faster than light? Picture this for a moment. You step aboard a spacecraft that humanity has somehow managed to build, one capable of breaking the ultimate speed limit of the universe. As you accelerate past that magical threshold of 186,282 miles per second, what unfolds around you isn't just a faster journey to distant stars. Instead, you've crossed into a realm where the fundamental laws of physics begin to behave in ways so strange, so counterintuitive, that they challenge our most basic assumptions about cause and effect, past and future, and the very nature of existence itself. The story I'm about to share with you isn't science fiction, though it certainly sounds like it. Every concept we'll explore tonight emerges from the rigorous mathematics of Einstein's relativity, the cutting-edge research of theoretical physicists, and the mind-bending implications of quantum mechanics. We're venturing into territory where Nobel Prize winners have spent decades wrestling with paradoxes that would make even the most imaginative science fiction writers pause in amazement. But here's what makes this journey so extraordinary. We're not just talking about getting from point A to point B more quickly. Faster than light travel would fundamentally break reality as we know it, creating possibilities so bizarre that they force us to reconsider everything we think we understand about time, causality, and the structure of the universe itself. Have you ever wondered why Einstein's speed limit exists in the first place? Why the universe seems so stubbornly determined to prevent anything from exceeding the speed of light? The answer isn't just about physics equations or abstract mathematical concepts. It's about the very foundations of reality and what happens when we dare to push beyond them. Tonight, we're going to discover that faster than light travel isn't just about reaching distant galaxies in the blink of an eye. It's about stepping into a world where you could potentially arrive at your destination before you even left, where the linear flow of time becomes negotiable, and where the grandfather paradox transforms from a philosophical thought experiment into a practical concern that could unravel the fabric of causality itself. We'll explore the mind-bending concept of time dilation, where travelling at extreme speeds doesn't just affect how fast you move through space, but literally changes how you move through time. Imagine leaving Earth as a 20-year-old and returning to find that while you've aged only a few months, everyone you knew has grown old and died. The implications aren't just scientific, they're profoundly human and deeply emotional. But the real mystery begins when we ask what lies beyond Einstein's cosmic speed limit. Recent breakthroughs in theoretical physics have revealed that there might actually be ways to circumvent this universal law without technically breaking it. Scientists have proposed mechanisms so elegant and so strange that they read like poetry written in the language of advanced mathematics. We'll journey through the theoretical landscape of Alcubierre warp drives, where space-time itself becomes your vehicle, contracting in front of your spacecraft and expanding behind it, creating a wave that carries you faster than light without ever actually accelerating your ship beyond Einstein's limit. It's like surfing on the fabric of reality itself, riding waves of curved space-time across the cosmic ocean. Then there are wormholes, those hypothetical tunnels through the universe that could connect distant regions of space and time like cosmic shortcuts. Imagine stepping through a doorway in New York and emerging instantly on a planet orbiting a star thousands of light years away. The mathematics suggests such pathways might be possible, though keeping them stable would require forms of exotic matter that may not even exist in our universe. We'll also encounter tachyons, those mysterious hypothetical particles that exist in a mirror world where faster means lower energy, where slowing down to the speed of light would require infinite power instead of infinite power to reach it. These ghostly entities, if they exist, would experience time flowing backward, creating a reality so alien that it challenges our most fundamental concepts of cause and effect. But perhaps the most unsettling aspect of our journey tonight will be confronting the paradoxes that faster-than-light travel creates. These aren't just abstract puzzles for physicists to ponder over coffee. They're fundamental challenges to the logical structure of reality itself. When you can travel faster than light, you can, under certain conditions, arrive at your destination before you left. This isn't just inconvenient for scheduling, it's a direct assault on causality, the principle that causes must precede their effects. The grandfather paradox becomes more than just a thought experiment. It becomes a genuine concern. If you could travel to the past, you could theoretically prevent your own birth, creating a logical contradiction that seems to tear holes in the fabric of reality. How does the universe resolve such paradoxes? The answers that physicists have proposed are as beautiful as they are bizarre. Some suggest that the universe splits into parallel timelines, where every possible outcome actually occurs in separate branches of reality. Others propose that reality has built-in protection mechanisms, quantum effects that prevent paradoxes from forming in the first place. Still others argue that time itself might be far more flexible than we assume, capable of healing its own wounds through mechanisms we're only beginning to understand. As we explore these possibilities tonight, we'll discover that the question of faster-than-light travel forces us to confront some of the deepest mysteries of existence. What is time really? Is it the steady, flowing river of our everyday experience, or something far more malleable and strange? What does it mean for something to be real if multiple contradictory versions of events can exist simultaneously? The journey we're about to take together will challenge not just your understanding of physics, but your conception of reality itself. We'll encounter ideas so profound that they've occupied the greatest minds in science for over a century, concepts so strange that they seem to belong more in the realm of philosophy than physics. But here's the beautiful thing about this exploration. Every concept we'll discuss, no matter how bizarre it might seem, emerges from serious scientific research. These aren't wild speculations or science fiction fantasies. They're the inevitable consequences of our best theories about how the universe actually works, pushed to their logical extremes. Recent developments in theoretical physics have brought some of these seemingly impossible concepts closer to the realm of possibility. New mathematical models suggest that warp drives might not require the exotic matter we once thought necessary. Quantum computers are beginning to demonstrate effects that seem to operate across multiple parallel realities simultaneously. Our understanding of the relationship between space, time, matter, and energy continues to evolve in ways that would have seemed magical just decades ago. So as we begin this extraordinary journey together, remember that you're not just learning about abstract physics concepts. You're exploring the fundamental nature of reality itself, peering into the deepest mysteries of existence, and discovering that the universe is far stranger, far more wonderful, and far more mysterious than our everyday experience suggests. The speed of light isn't just a number in a physics textbook. It's the cosmic speed limit that shapes the very structure of space and time. And tonight we're going to discover what happens when that limit is challenged, bent, and potentially broken. We're going to explore a realm where the impossible becomes merely improbable, where the paradoxical becomes practical, and where the journey itself transforms not just our destination, but our understanding of what it means to exist in this magnificent, mysterious universe. So settle in, dear fellow travellers, as we prepare to accelerate beyond the ultimate barrier into a realm where physics becomes poetry, where mathematics reveals magic, and where the question of what would really happen if you travelled faster than light opens doorways to wonders beyond imagination. The cosmic speed limit awaits, and we're about to discover what lies beyond it. To truly understand what would happen if you could travel faster than light, we must first appreciate the profound elegance of Einstein's cosmic speed limit and why it exists at all. You see, the speed of light isn't arbitrary, some random number that the universe happened to choose. It's woven into the very fabric of reality itself, a fundamental constant that shapes everything, from the flow of time to the nature of causality. When Einstein first unveiled his theory of special relativity in 1905, he revealed something extraordinary about our universe. As any object with mass approaches the speed of light, something remarkable and terrifying begins to happen. The object's mass doesn't just stay constant, it starts to increase, growing larger and larger as speeds approach that magical threshold of 186,282 miles per second. Imagine trying to push a shopping cart that becomes heavier with every step you take. At first it rolls easily, but as you walk faster, it grows more massive, requiring more and more effort to maintain your pace. By the time you're approaching the speed of light, that shopping cart would have the mass of a mountain, then a planet, then eventually the entire observable universe. The energy required to push it just 1 mile per hour faster would become infinite. This isn't a limitation of our technology or engineering capabilities. It's a fundamental feature of reality itself, as immutable as the fact that circles are round or that 2 + 2 = 4. The universe has essentially built an unbreakable barrier into the very structure of existence, and for over a century, physicists have wondered why. But what if we could somehow circumvent this limitation? What if there were ways to travel faster than light without technically violating Einstein's prohibition? The theoretical landscape of modern physics suggests several fascinating possibilities, each more mind-bending than the last. The first and perhaps most elegant solution comes from a Mexican physicist named Miguel Alcubierre, who in 1994 proposed something that sounds like pure science fiction, but emerges from rigorous mathematical analysis of Einstein's field equations. Rather than accelerating a spacecraft to impossible speeds, the Alcubierre drive would manipulate spacetime itself, creating a bubble around the vessel where space contracts in front and expands behind. Picture yourself floating on a surfboard, not on ocean waves, but on waves of spacetime itself. The water ahead of your board compresses, becoming denser, while the water behind stretches and expands. You're not moving through the water at all. You're riding the wave as it carries you forward at speeds that could theoretically exceed light itself. The spacecraft inside this bubble would experience normal physics, never actually accelerating beyond Einstein's limit, while the bubble itself surfs across the cosmos faster than photons travelling through normal space. The mathematics are breathtaking in their elegance. According to Alcubierre's calculations, such a drive could theoretically transport you to Proxima Centauri, our nearest stellar neighbour, in a matter of days rather than the 4.2 years it takes light to make the journey. Distant galaxies millions of light years away could become accessible within a human lifetime. The entire observable universe could become humanity's neighbourhood. But here's where the dream encounters harsh reality. The energy requirements for creating such space-time distortions are almost incomprehensibly vast. Early calculations suggested that powering an Alcubierre drive would require negative energy equivalent to the mass energy of the planet Jupiter, converted entirely into this exotic fuel. Some estimates pushed the requirements even higher, demanding energy equivalent to the mass of the entire observable universe. Also, negative energy, you see, isn't just difficult to obtain, it's a form of matter so exotic that we're not even certain it can exist in the quantities needed. It would possess gravitational properties opposite to normal matter, repelling rather than attracting, creating regions of space where the usual rules of physics bend in extraordinary ways. Yet recent theoretical breakthroughs have offered glimmers of hope. In 2021, physicist Eric Lentz proposed modifications to the Alcubierre concept that could potentially eliminate the need for exotic matter altogether. His calculations suggest that conventional positive energy, arranged in specific configurations and moving in carefully orchestrated patterns, might create similar space-time distortions. The energy requirements remain staggering, still equivalent to the mass energy of large planets, but they're no longer infinite. They've moved from the realm of the absolutely impossible to the merely extraordinarily difficult. It's the difference between needing all the energy in the universe and needing merely the energy output of a large star. Meanwhile, other theoretical pathways to faster-than-light travel have emerged from the strange landscape of quantum mechanics and general relativity. Wormholes, those hypothetical tunnels through spacetime, offer another tantalizing possibility. Unlike the Alcubierre drive, which manipulates space around a traveling vessel, wormholes would create shortcuts through the very geometry of the universe itself. Imagine the universe as a vast sheet of paper, with Earth on one corner and a distant star system on the opposite corner. Travelling the normal route would require crossing the entire sheet, a journey of millions of light years, taking millions of years, even at light speed. But if you could fold that paper so the two corners touch, then poke a hole through both layers, you'd create a tunnel that connects distant regions through a shortcut that bypasses normal space entirely. The journey through such a wormhole wouldn't involve faster-than-light travel in the conventional sense. You'd never exceed Einstein's speed limit locally. Instead, you'd be taking a much shorter route through the folded geometry of space-time itself. It's like discovering a hidden passage in a vast mansion that connects the basement directly to the attic, bypassing all the floors in between. But wormholes come with their own set of seemingly insurmountable challenges. Most theoretical wormholes would be inherently unstable, collapsing the moment anything tried to pass through them. Keeping them open would likely require the same exotic matter needed for Alcubierre drives, threading the tunnel with materials that possess negative energy density to prevent gravitational collapse. Even more intriguingly, some wormholes might not just connect different regions of space but different moments in time. A wormhole could theoretically link today with yesterday, or this year with the next century. Step through one end in 2024 and emerge from the other in 1924, creating possibilities for time travel that make science fiction seem conservative in its imagination. This brings us to perhaps the most unsettling consequence of faster-than-light travel. The fact that under Einstein's relativity, anything that can travel faster than light can also be used to send information backward through time. This isn't a side effect or an unintended consequence. It's a fundamental feature of how space-time works, as inevitable as gravity pulling objects downward. The mechanism is elegantly simple, yet profoundly disturbing. Different observers moving at different speeds through space experience time differently. What appears simultaneous to one observer happens in sequence to another. If you could send a signal faster than light, there would always be some reference frame where that signal arrived before it was sent. This creates what physicists call the tachyonic anti-telephone, a communication device that could theoretically send messages into the past. Imagine calling your younger self to warn about mistakes you haven't made yet, or receiving stock tips from your future self about investments that haven't been invented. The logical paradoxes multiply endlessly, each more mind-bending than the last. The grandfather paradox, that classic time travel conundrum, transforms from philosophical thought experiment to practical engineering problem. If you could travel faster than light, you could potentially journey to the past and prevent your own birth, but if you were never born, who went back in time to cause the prevention? The logical contradiction seems to tear holes in the fabric of reality itself. Some physicists have proposed that the universe might have built-in protection mechanisms against such paradoxes. Stephen Hawking's chronology protection conjecture suggests that quantum effects would always prevent the formation of closed time-like curves, those paths through space-time that loop back to their own past. Whenever you try to create a time travel scenario, the universe would somehow conspire to prevent it, perhaps through quantum fluctuations that destroy wormholes or exotic matter that refuses to behave as predicted. Others embrace the paradoxes, suggesting that they reveal something profound about the nature of reality itself. The many worlds interpretation of quantum mechanics proposes that every possible outcome of every quantum event actually occurs, but in separate parallel universes. In this view, travelling to the past wouldn't change your original timeline, but would create a new branch of reality where different events unfold. You could kill your grandfather in the past, but you'd simply be creating an alternate universe where you were never born. Your original timeline would continue unchanged, while you become a visitor in a parallel reality shaped by your intervention. The paradox resolves because you're not changing the past. You're exploring the infinite garden of possible histories that quantum mechanics reveals. But perhaps the most exotic theoretical particles in physics offer the strangest perspective on faster-than-light travel. Tachyons, hypothetical particles that always travel faster than light, would inhabit a mirror universe where the familiar rules of physics operate in reverse. For normal matter, it takes infinite energy to reach light speed. For tachyons, it would take infinite energy to slow down to light speed. These ghostly entities would experience time flowing backward, existing in a realm where effects precede causes and the future influences the past. A tachyon created today would have been travelling forever, its existence stretching infinitely into the past. Detecting such particles would be like trying to observe something that arrives before it's created, existing before it comes into being. The very existence of tachyons would revolutionize our understanding of causality and time. They could theoretically carry information from future events backward through time, creating a universe where prophecy becomes physics and prediction becomes as reliable as memory. Yet despite decades of searching, no experimental evidence for tachyons has ever been found, leaving them in the realm of fascinating theoretical possibility. As we explore these exotic realms of physics, we begin to realize that faster-than-light travel isn't just about transportation. It's about fundamentally altering the relationship between space and time, cause and effect, possibility and reality. Each theoretical pathway beyond Einstein's speed limit opens doorways to stranger and more wonderful universes than our everyday experience suggests. The implications extend far beyond the realm of physics into philosophy, consciousness, and the very meaning of existence itself. If multiple timelines can coexist, if causes can follow effects, if the future can influence the past, then what does it mean to make choices? What constitutes free will in a universe where every decision creates new branches of reality? Recent developments in quantum computing have added new dimensions to these questions. Quantum computers achieve their extraordinary processing power by performing calculations in multiple parallel realities simultaneously, borrowing computational resources from alternate versions of themselves scattered throughout the multiverse. It's as if these devices are already demonstrating that the boundaries between different realities are more porous than we typically assume. The relationship between consciousness and quantum mechanics remains one of the deepest mysteries in science. Some interpretations suggest that conscious observation plays a fundamental role in determining which quantum possibilities become real. If this is true, then perhaps consciousness itself is a kind of faster-than-light phenomenon, instantaneously collapsing quantum probabilities across vast distances without being limited by Einstein's speed restrictions. This consciousness-based view of reality suggests that the question of faster-than-light travel might not be primarily about building exotic spacecraft or manipulating space-time, but about understanding the nature of awareness itself. Perhaps the key to transcending physical limitations lies not in advanced technology, but in expanded consciousness, in learning to navigate the quantum landscape of possibility with intention and wisdom. The journey continues to unfold as we delve deeper into these mysteries, each revelation opening new questions, each answer revealing greater depths of cosmic wonder. The universe, it seems, is far stranger and more magnificent than our current understanding suggests, filled with possibilities that challenge our most basic assumptions about the nature of reality itself. As we drift deeper into these theoretical waters, we encounter what might be the most profound implication of faster-than-light travel, the complete transformation of human experience itself. You see, the moment we step beyond Einstein's cosmic speed limit, we're not just changing how we move through space, we're fundamentally altering our relationship with time, memory, and the very fabric of personal identity. Consider the twin paradox, that elegant thought experiment that reveals the deeply personal consequences of relativistic travel. Imagine you have an identical twin, born just minutes after you on the same day. You both grow up together, sharing childhood memories, celebrating birthdays, aging at exactly the same pace. Then one day, you climb aboard a spacecraft capable of traveling at 99% the speed of light, leaving your twin behind on Earth. From your perspective aboard the speeding vessel, the journey to a distant star system takes perhaps 5 years. You age 5 years, accumulate 5 years of memories, experience 5 years of dreams and thoughts and moments of wonder as you sail through the cosmic ocean. But when you return to Earth, something extraordinary and heartbreaking has occurred. Your twin, who remained in Earth's slower-moving reference frame, has aged 50 years. The person who was once your contemporary, your mirror image, your closest companion in time, is now decades older than you. They've lived through experiences you'll never share, accumulated wisdom from years you never experienced, perhaps raised children and grandchildren you'll meet for the first time as an elderly stranger visiting from the past. You've become unstuck in time, a visitor from an earlier era suddenly thrust into a future you helped create, but never lived through. This isn't just mathematics or abstract physics. This is the lived reality of what faster-than-light travel would mean for human relationships, for love, for the connections that give life meaning. Every journey beyond Einstein's speed limit becomes a one-way ticket not just through space, but through time itself, separating travelers from the temporal community of those they leave behind. But the implications grow even stranger when we consider that faster-than-light travel could theoretically allow you to witness your own past. Through carefully planned routes involving multiple high-speed journeys and gravitational time dilation effects, you could potentially return to Earth before you ever left, becoming a spectator to your own departure. Imagine watching yourself board that spacecraft, seeing the younger version of yourself disappear into the cosmic distance while you, the older traveller, observe from the shadows of your own history. The psychological implications are staggering. How do you maintain a coherent sense of self when you can literally encounter previous versions of yourself? What happens to personal identity when the linear progression of experience becomes negotiable? When the story of your life can be experienced out of order, or even simultaneously, from multiple perspectives? Recent theoretical work in quantum mechanics suggests that such encounters might not just be possible, but inevitable in a universe where faster-than-light travel exists. The many worlds interpretation proposes that every quantum measurement creates multiple parallel realities, each containing slightly different versions of everyone and everything. If faster-than-light travel allows access to these parallel timelines, you might find yourself meeting not just your past self, but alternate versions of yourself who made different choices, lived different lives, became different people. Imagine encountering a version of yourself who chose a different career, married a different person, lived in a different city. They would be you, possessing your memories up to the point where your timelines diverged, but they would also be fundamentally different, shaped by experiences you never had, carrying knowledge you never acquired. Which version would be the real you? How would you integrate the knowledge that countless alternate selves exist throughout the multiverse, each living lives you might have lived? The philosophical implications extend into the realm of free will and moral responsibility. If every possible choice creates new branches of reality, if alternate versions of yourself are making every decision you don't make, then what meaning does choice itself possess? Are you responsible for actions taken by alternate selves in parallel timelines? Do you deserve credit for achievements accomplished by versions of yourself in realities you've never visited? These questions become practical concerns when faster-than-light travel makes interaction between timelines possible. Some theoretical models suggest that sufficiently advanced civilizations might develop technologies that allow communication or even travel between parallel realities. You could theoretically send messages to alternate versions of yourself, sharing knowledge and experiences across the branches of the quantum multiverse. But such capabilities would raise profound ethical dilemmas. Would it be fair to warn an alternate self about disasters you've already experienced? Would sharing knowledge gained through suffering diminish the value of the lessons learned? If you could prevent tragedies in parallel timelines, would you have a moral obligation to do so, even if it meant altering the fundamental character of those realities? The nature of memory itself becomes questionable in a universe where faster-than-light travel enables time travel. Currently, memory serves as our anchor to personal continuity, the thread that connects our past self to our present awareness. But what happens when you can travel to moments you remember, observing them from outside your own experience? Would watching your childhood from an adult perspective change how you remember those events? Would the memory of remembering alter the original memory itself? Some physicists have proposed that time travel might naturally resolve such paradoxes through quantum effects that blur the boundaries between memory and experience. Perhaps travelers to the past would find their memories of the future gradually fading, ensuring that knowledge of upcoming events doesn't create causal loops. You might remember planning to travel to the past, but once you arrive, the details of the future you came from would become increasingly hazy, like trying to recall a dream after waking. This quantum amnesia would serve as a natural protection mechanism, preventing time travelers from accumulating infinite knowledge by repeatedly visiting the same events. Each journey to the past would be like diving into a pool of temporal forgetfulness, emerging with experiences but not with detailed foreknowledge that could destabilize causality. The social implications of faster-than-light travel extend far beyond individual psychology into the realm of civilization itself. If some humans can travel at relativistic speeds, while others remain bound to normal timeframes, society would inevitably stratify along temporal lines. The time-rich would accumulate advantages impossible for others to match, experiencing multiple lifetimes while their contemporaries age through just one. Imagine a world where the wealthy can afford faster-than-light travel, using time dilation to extend their lives, while the poor remain trapped in normal, temporal flow. A business leader could make a journey to a nearby star system, returning after subjective months to find that decades have passed on Earth. Markets they invested in would have matured, technologies they funded would have developed, while they remained young enough to enjoy the benefits of their foresight. Such temporal inequality would create new forms of injustice more profound than any economic disparity we currently understand. The gap between the time-rich and time-poor wouldn't just be measured in wealth or opportunity, but in actual lifespan, in the fundamental experience of existence itself. Those with access to faster-than-light travel could potentially live for millennia, while their earthbound contemporaries experience normal human lifespans. The development of language and communication would face unprecedented challenges in a faster-than-light civilization. How do you maintain cultural continuity when different groups of humans are experiencing time at different rates? What happens to shared traditions, common knowledge, collective memory, when some members of society are aging decades while others experience only months? Perhaps most intriguingly, faster-than-light travel might reveal that consciousness itself operates according to principles that transcend our current understanding of physics. Some interpretations of quantum mechanics suggest that awareness plays a fundamental role in determining which possibilities become real, that the act of observation somehow shapes reality at the quantum level. If consciousness possesses this reality-shaping power, then perhaps the key to faster-than-light travel lies not in advanced technology, but in expanded awareness. Maybe the universe is structured in such a way that sufficiently developed consciousness can transcend physical limitations, accessing information and experiences across space and time through mechanisms that operate outside the normal constraints of relativity. This consciousness-based approach to faster-than-light phenomena suggests that the boundaries between mind and matter, between observer and observed, might be more fluid than our everyday experience indicates. Perhaps what we call physical travel is just one limited expression of consciousness, exploring its own infinite possibilities. Recent developments in neuroscience have revealed that the human brain operates as a kind of biological quantum computer, processing information in ways that seem to transcend classical physics. Some researchers propose that consciousness might naturally access information from multiple quantum states simultaneously, experiencing what we call intuition or inspiration as glimpses of alternate possibilities existing in parallel realities. If this is true, then perhaps we're already engaged in a primitive form of faster-than-light travel every time we dream, every time we imagine, every time we reach beyond the boundaries of immediate sensory experience to touch possibilities that exist beyond the here and now. The journey to transcend Einstein's speed limit might begin not with exotic matter or warped space-time, but with understanding the true nature of awareness itself. The implications ripple outward, like waves in a cosmic pond, touching every aspect of what it means to be human in a universe where the impossible becomes merely improbable. As we continue our exploration of these theoretical realms, we find ourselves confronting not just the limits of physics, but the boundaries of imagination itself. Each new possibility we encounter reveals deeper layers of mystery. Each answer we discover opens doorways to more profound questions. The universe, it seems, is far more generous with its gifts of wonder than we ever dared imagine, offering pathways to transcendence that stretch far beyond our current ability to comprehend or describe. And yet, in the gentle quiet of this moment, as these ideas settle into your awareness, like starlight on still water, you're already participating in something extraordinary. Your consciousness, right now, is reaching across impossible distances to touch these cosmic possibilities, bridging the gap between the finite and infinite through the simple miracle of wonder itself. The journey continues, carrying us deeper into realms where physics becomes poetry, where mathematics reveals magic, and where the question of what would happen if you travelled faster than light opens doorways to understanding that stretch beyond the very concepts of space and time themselves. But perhaps the most unsettling revelation about faster-than-light travel lies in how it would fundamentally shatter our understanding of cause and effect, transforming the universe from a place where events unfold in logical sequence into a cosmic theatre where the future can reach backward to influence its own past. To truly grasp this mind-bending reality, imagine yourself standing at a train station, watching two locomotives approach from opposite directions. In our normal world, you see the trains coming, you step aside, and they pass by in a predictable sequence. But in a universe where information can travel faster than light, something extraordinary happens. The sound of the second train's whistle reaches you before the first train has even appeared on the horizon. Effects begin preceding their causes, and the comfortable logic of sequential time dissolves into something far more mysterious. This isn't just a curious side effect of faster-than-light travel. It's an inevitable consequence of how space-time itself is structured. Einstein's relativity reveals that simultaneity, the idea that two events happen at the same moment, is relative to the observer. What appears to occur at the same instant to someone standing still happens in clear sequence to someone moving at high speed. When you introduce faster-than-light signals into this relativistic framework, you create situations where every observer, regardless of their motion, would witness events occurring before their causes. The implications are staggering. Picture yourself sending a faster-than-light message to a friend on a distant planet, warning them about an asteroid impact that hasn't happened yet. From their perspective, moving at a different velocity through space, your warning arrives before the asteroid even begins its journey toward their world. They send a reply back to you, also travelling faster than light, and that reply reaches you before you sent the original message. Suddenly, you're receiving responses to conversations you haven't yet begun, answers to questions you haven't thought to ask. This creates what physicists call closed time-like curves, pathways through space-time that loop back on themselves like cosmic figure eights. Following such a curve, you could theoretically witness the entire sequence of cause and effect play out in reverse, watching effects shrink back into their causes, seeing the future collapse into the past, like a movie played backward. The psychological implications of living in such a universe would be profound beyond imagination. How do you make decisions when you might receive information about their consequences before you've made them? How do you maintain free will when the future is constantly sending messages backward through time, potentially influencing the very choices that create it? Some of the most brilliant minds in physics have wrestled with these paradoxes for decades, proposing solutions that range from the elegant to the bizarre. Stephen Hawking suggested that the universe might possess what he called chronology protection, a kind of cosmic immune system that prevents causality violations from forming in the first place. Whenever conditions arise that could create a time travel scenario, quantum effects would spontaneously emerge to prevent it, like antibodies destroying an infection before it can spread. This protection might manifest in countless subtle ways. Wormholes that could serve as time machines would spontaneously collapse the moment anything tried to pass through them. Exotic matter required for faster-than-light travel would refuse to maintain the necessary properties. Even if you built a perfect time machine, quantum fluctuations would destroy it at the precise moment you attempted to use it. The universe, in essence, would conspire to protect its own logical consistency. But other physicists have embraced the paradoxes, suggesting that they reveal something profound about the nature of reality itself. The many worlds interpretation of quantum mechanics proposes that every possible outcome of every quantum event actually occurs, but in separate parallel universes. In this view, Faster-than-light travel wouldn't violate causality, but would simply provide access to the infinite garden of alternate realities that quantum mechanics reveals. You could travel back in time and prevent your own birth, but you wouldn't be erasing yourself from existence. Instead, you'd be creating a new branch of reality where you were never born, while your original timeline continues unchanged. The grandfather paradox resolves because you're not changing the past. You're exploring alternate histories. Every possible version of events exists somewhere in the quantum multiverse, and faster-than-light travel becomes a means of navigating between these parallel possibilities. This multiverse perspective transforms faster-than-light travel from a transportation technology into something far more profound, a method for exploring the fundamental structure of reality itself. Each journey beyond the speed of light would be like stepping through a doorway into alternate worlds, experiencing realities where different choices were made, different paths taken, different futures realized. Recent developments in quantum computing have lent unexpected support to these multiverse theories. Quantum computers achieve their extraordinary processing power by performing calculations simultaneously across multiple parallel realities, borrowing computational resources from alternate versions of themselves scattered throughout the quantum landscape. It's as if these devices are already demonstrating that the boundaries between different realities are more porous than we typically assume. The implications extend into the realm of consciousness itself. If quantum computers can access parallel realities for processing power, perhaps human consciousness operates according to similar principles. Maybe what we call intuition, creativity, or inspiration represents our minds naturally accessing information from alternate versions of ourselves existing in parallel timelines. This consciousness-based view suggests that faster-than-light travel might not require exotic spacecraft or manipulated space-time at all. Perhaps the key lies in understanding how awareness itself transcends the normal limitations of space and time. Every moment of deep insight, every flash of understanding that seems to come from nowhere, every dream that carries us to impossible places might be evidence of consciousness naturally operating faster than light. The mathematics of consciousness remain one of the deepest mysteries in science. We know that the human brain contains roughly 86 billion neurons, each connected to thousands of others through synapses that fire in patterns of staggering complexity. Yet somehow, from this biological network emerges something that can contemplate infinity, imagine realities that don't exist, and reach across vast distances to touch the minds of others through language and shared experience. Perhaps consciousness represents a form of faster-than-light phenomenon that we experience so naturally we don't recognize its extraordinary nature. When you remember a childhood moment, you're instantly accessing information from decades in the past. When you imagine a possible future, you're exploring realities that haven't yet come into being. When you feel a connection with someone far away, you're bridging distances that would take light significant time to cross. This perspective suggests that the boundaries we typically assume between mind and matter, between consciousness and cosmos, might be far more fluid than our everyday experience indicates. If awareness can naturally transcend space and time, then perhaps the question of faster-than-light travel is really a question about the nature of consciousness itself. Some of the most intriguing theoretical work in modern physics explores the possibility that information, rather than matter or energy, might be the most fundamental aspect of reality. In this informational view of the universe, everything we experience as solid, real, and permanent is actually patterns of information processing, like pixels on a cosmic computer screen that create the illusion of three-dimensional reality. If this is true, then faster-than-light travel might not involve moving matter through space at all, but rather transmitting the information patterns that define objects and beings across vast distances instantaneously. Your consciousness, your memories, your essential self would be encoded as pure information, and transmitted faster than light to distant locations, where that information would be decoded back into physical form. The philosophical implications are staggering. Would the reconstructed version of yourself at the destination be the same person who began the journey, or would it be a copy that merely believes it has your memories and experiences? If your original body were destroyed in the transmission process, would you have achieved faster than light travel, or would you have simply created a duplicate while ceasing to exist yourself? These questions push us into territory where physics merges with philosophy, where scientific inquiry meets the deepest mysteries of personal identity and consciousness. They force us to confront fundamental questions about what makes you uniquely you, whether identity resides in the physical structure of your brain or in the pattern of information that gives rise to your thoughts and memories. Recent experiments in quantum mechanics have demonstrated that information can indeed be transmitted instantly across vast distances through quantum entanglement. That spooky action at a distance that Einstein famously disliked. When two particles become entangled, measuring one immediately affects the other, regardless of the distance separating them. While this quantum correlation can't be used to send conventional messages faster than light, it proves that some aspects of reality do operate through instantaneous connections that transcend normal space and time. Perhaps consciousness itself operates through similar quantum entanglements, creating connections between minds that exist outside the normal constraints of relativity. The feeling of instant understanding between close friends, the way thoughts and emotions seem to synchronize between people who love each other, the uncanny ability of parents to sense when their children are in distress across great distances, all of these might be evidence of consciousness naturally accessing faster than light channels of communication. This quantum view of consciousness suggests that we might already be living in a universe where faster than light phenomena are commonplace, operating through mechanisms so subtle and natural that we've never recognized them as violations of Einstein's speed limit. Every moment of shared understanding, every flash of insight, every experience of connection that transcends physical distance might be glimpses of consciousness operating according to principles that stretch far beyond our current scientific understanding. The journey into these theoretical realms reveals that faster than light travel isn't just about reaching distant destinations more quickly. It's about discovering new ways of being, new forms of existence that transcend the limitations we typically assume are absolute. Whether through exotic matter and warped space-time, through quantum entanglement and parallel realities, or through the expansion of consciousness itself, the pathways beyond Einstein's speed limit offer doorways to experiences that would transform not just how we move through the universe, but how we understand our place within it. As we float deeper into these possibilities, each more extraordinary than the last, we begin to see that the question of what would happen if you travelled faster than light opens onto mysteries that stretch far beyond the realm of physics into the deepest territories of existence itself. The universe, it seems, is far more generous with its gifts of wonder than we ever dared imagine, offering pathways to transcendence that challenge every assumption we hold about the nature of reality. And perhaps most beautifully, this exploration reveals that you are already participating in phenomena that transcend the normal boundaries of space and time. Every thought that reaches across impossible distances to touch these cosmic possibilities, every moment of wonder that connects your finite awareness to infinite mystery, every breath that synchronizes your being with the rhythm of the cosmos itself represents a form of faster-than-light travel that makes any mechanical device seem crude by comparison. The cosmic speed limit awaits our understanding, and the journey to transcend it begins not with exotic technology, but with the recognition that consciousness itself might be the ultimate faster-than-light phenomenon, already operating according to principles that stretch far beyond anything our current physics has yet discovered or described. But the strange world of faster-than-light travel reveals even more profound mysteries when we consider the exotic matter that such journeys might require. You see, to power an Alcubierre drive or stabilize a traversable wormhole, we would need something that exists only in the realm of theoretical physics, a substance so alien to our everyday experience that it challenges our most basic understanding of what matter can be. This exotic matter would possess what physicists call negative energy density, meaning it would have gravitational properties opposite to everything we've ever encountered. While normal matter pulls other objects toward it through gravity's attractive force, exotic matter would push things away, creating regions of space where the familiar rules of physics bend in extraordinary ways. It would be like discovering that some water flows uphill, that some flames freeze rather than burn, that some shadows emit light rather than absorb it. The mathematical requirements are as beautiful as they are bizarre. To create a stable wormhole connecting Earth to Alpha Centauri, you would need to thread the tunnel with ribbons of this exotic matter, maintaining precise concentrations that prevent the passage from collapsing under its own gravitational stress. The amount required would be staggering, equivalent to the mass of entire planets, but with energy properties that exist nowhere in our observable universe. Recent theoretical breakthroughs have suggested that nature might provide glimpses of such exotic conditions through quantum effects that operate at the smallest possible scales. The Casimir effect, discovered when two metal plates are placed extraordinarily close together in a vacuum, demonstrates that regions of truly empty space can indeed possess negative energy density. Between those plates, the quantum vacuum itself creates a measurable force that pulls the surfaces together, proving that the universe already contains the seeds of the exotic matter we would need. But scaling such quantum effects up to macroscopic proportions presents challenges that stretch even our most optimistic projections. The negative energy created by the Casimir effect exists in quantities so minuscule that billions of years of accumulation wouldn't provide enough exotic matter to power a journey to the nearest star. It's like trying to fill an ocean with drops of morning dew, each precious but insufficient for the vast enterprise we're contemplating. Yet some physicists have proposed ingenious solutions that could amplify these quantum effects through carefully designed metamaterials and exotic field configurations. Imagine arrays of microscopic structures, each one engineered to concentrate and stabilize the negative energy that quantum mechanics allows. These devices would be like cosmic harvesting machines, gathering the exotic matter that space-time itself produces naturally, accumulating it slowly but steadily until sufficient quantities exist to power our faster-than-light dreams. The energy scales involved boggle the imagination in ways that numbers alone cannot convey. To create a warp bubble large enough to transport a small spacecraft would require energy equivalent to converting the entire mass of Jupiter into pure power. Not just the energy that Jupiter receives from the Sun, or the energy stored in its atmospheric storms, but the complete mass energy of the entire planet. Every atom transformed, according to Einstein's famous equation, into the exotic fuel needed for faster-than-light propulsion. But here's where recent theoretical work offers unexpected hope. Dr. Eric Lentz's revolutionary calculations suggest that certain configurations of conventional matter, arranged in precise geometric patterns and accelerated to extraordinary speeds, might create the space-time distortions we need without requiring exotic matter at all. His hyperfast Soliton waves represent a completely different approach to warping space, using the universe's own geometry as a propulsion system. These Soliton solutions are like waves that maintain their shape while traveling faster than light, carrying bubbles of normal space-time along with them. The mathematics are staggeringly complex, involving field equations that stretch across multiple dimensions and require computational resources that push our most advanced supercomputers to their limits. Yet the fundamental insight is elegantly simple. If you can create the right kind of wave in the fabric of space itself, That wave can carry you to destinations faster than light could reach through normal space-time. The practical challenges remain enormous. Creating such soliton waves would still require energy equivalent to the mass of large planets, and the precise control needed to maintain them would demand technologies we can barely imagine. But the energy is at least theoretically obtainable using conventional matter and known physics, moving the concept from the realm of the impossible to the merely extraordinarily difficult. Meanwhile, the search for naturally occurring faster-than-light phenomena has led physicists to examine the most extreme environments in our universe. Near the event horizons of rotating black holes, space-time itself gets dragged along by the immense gravitational fields, creating regions where the normal relationship between space and time becomes fluid and strange. Some theoretical models suggest that within these twisted space-time geometries, faster-than-light travel might occur naturally without requiring exotic matter or artificial manipulation. These rotating black holes, called Kerr black holes after the mathematician who first described them, possess an ergosphere, a region outside the event horizon where space-time is dragged along so violently that nothing can remain stationary relative to distant stars. Within this bizarre realm, the very definition of standing still becomes meaningless, and particles might be accelerated to speeds that exceed light itself relative to observers far from the black hole's influence. The implications stretch beyond academic physics into the realm of practical possibility. If advanced civilizations could harness the natural space-time distortions around rotating black holes, they might achieve faster-than-light travel using the universe's own most powerful gravitational engines. It would be like learning to surf on waves created by cosmic storms, riding the natural turbulence of space-time itself across the vast distances between stars. But perhaps the most intriguing aspect of faster-than-light physics lies in its connection to the fundamental nature of information itself. Recent work in quantum information theory suggests that reality might be built from information at the most basic level, with matter and energy emerging as patterns in an underlying computational substrate. If this informational view of the universe proves correct, then faster-than-light travel might not involve moving objects through space at all, but rather transmitting the information patterns that define those objects across vast distances instantaneously. This perspective transforms faster-than-light travel from a transportation problem into a communication challenge. Instead of accelerating your physical body beyond the speed of light, you would encode your complete information pattern, every atom, every quantum state, every memory and thought, and transmit that data to a distant location where it would be reconstructed into physical form. The journey would be instantaneous from your perspective, like stepping through a doorway and emerging light years away without experiencing the passage of time. The philosophical implications are profound. Would the reconstructed version of yourself be the same person who began the journey, or would it be a perfect copy that merely believes it has your memories and experiences? If multiple copies could be created simultaneously at different destinations, which one would be the real you? These questions push us into territory where physics meets philosophy, where scientific inquiry encounters the deepest mysteries of personal identity and consciousness. Recent experiments in quantum teleportation have demonstrated that such information transfer is not just theoretically possible, but practically achievable. Scientists have successfully transmitted the complete quantum state of particles across significant distances, destroying the original while perfectly recreating it at the destination. The process preserves every measurable property of the original particle, suggesting that identity might indeed reside in information patterns rather than in specific physical matter. Scaling such quantum teleportation up to complex objects like human beings would require computational resources that dwarf anything we can currently imagine. The information content of a single human body, encoded down to the quantum level, would fill storage devices larger than entire planets. Processing and transmitting such vast quantities of data would require technologies that make our most advanced computers seem like stone tools by comparison. Yet the theoretical foundation appears sound. If consciousness emerges from information patterns rather than from specific physical substrates, then quantum teleportation could theoretically preserve not just your body, but your mind, your memories, your essential self across arbitrary distances instantaneously. Death and resurrection would become routine aspects of interstellar travel, with passengers dissolving into pure information at one end of their journey and materializing as identical copies at their destination. The social implications of such technology would revolutionize human civilization in ways we can barely begin to imagine. If consciousness can be transmitted instantly across cosmic distances, then the barriers that currently isolate different worlds would dissolve overnight. Earth could maintain real-time communication and even physical exchange with colonies scattered throughout the galaxy, creating a truly interstellar human community. But the technology would also raise unprecedented ethical questions. If copies of people can be created at will, what happens to the uniqueness of individual identity? If someone could exist simultaneously at multiple locations throughout the galaxy, which version would possess legal rights, emotional relationships, property ownership? The very concept of personal continuity would require complete redefinition in a world where consciousness becomes as transmissible as any other form of information. The quantum nature of consciousness itself remains one of the deepest mysteries in science. Some researchers propose that awareness emerges from quantum processes occurring within the microtubules of brain cells, creating a biological quantum computer that processes information according to principles that transcend classical physics. If consciousness operates through quantum entanglement and superposition, then perhaps the boundaries we assume between individual minds are more fluid than we typically recognize. This quantum view of consciousness suggests that faster-than-light communication might already be occurring naturally between entangled minds, creating connections that operate outside the normal constraints of space and time. The instant understanding that sometimes occurs between close friends, the way emotions seem to synchronize between people who love each other, the uncanny ability of parents to sense their children's distress across great distances, all of these phenomena might represent consciousness naturally accessing faster-than-light channels of communication. Recent research in quantum biology has revealed that living systems routinely exploit quantum effects that were once thought too delicate to survive in warm, noisy, biological environments. Photosynthesis uses quantum coherence to achieve near-perfect energy transfer efficiency. Some birds appear to navigate using quantum entanglement in their visual systems. Even human consciousness might depend on quantum processes that connect our minds to the deeper quantum structure of reality itself. If biological systems can harness quantum effects for practical purposes, then perhaps the path to faster-than-light travel lies not in building exotic spacecraft, but in understanding and enhancing the quantum processes that already operate within living organisms. Maybe consciousness itself is already a faster-than-light phenomenon, naturally transcending the speed of light through quantum channels we haven't yet learned to recognize or control. This biological approach to faster-than-light phenomena suggests that the key might lie in evolution rather than engineering, in developing our natural quantum capabilities rather than building artificial devices. Perhaps sufficiently advanced beings could learn to consciously control their quantum entanglements, projecting their awareness instantly across cosmic distances without requiring any external technology at all. The implications extend into the realm of interstellar communication and the search for extraterrestrial intelligence. If consciousness can naturally operate faster than light through quantum channels, then advanced civilizations might already be communicating through methods we haven't yet learned to detect. The silence we observe when listening for radio signals from other worlds might simply reflect our ignorance of the quantum communication networks that connect conscious beings throughout the galaxy. As we drift deeper into these theoretical possibilities, we begin to see that faster-than-light travel represents more than just a transportation technology. It's a window into the fundamental nature of reality itself, revealing aspects of existence that challenge our most basic assumptions about space, time, matter, and consciousness. Each pathway we've explored, from Alcubierre drives to quantum teleportation, from exotic matter to consciousness-based travel, opens doorways to universes stranger and more wonderful than our everyday experience suggests. The journey continues to unfold, carrying us deeper into realms where the impossible becomes merely improbable, where the paradoxical becomes practical, and where the question of what would happen if you travelled faster than light reveals that the universe is far more generous with its gifts of mystery and wonder than we ever dared imagine. The cosmic speed limit stands before us not as an insurmountable barrier, but as an invitation to transcend our current understanding and discover new ways of being that stretch beyond the boundaries of everything we thought we knew about the nature of existence itself. And yet, as we float through these extraordinary theoretical landscapes, we encounter what might be the most startling revelation of all about faster-than-light travel. The moment you step beyond Einstein's cosmic speed limit, you don't just change your relationship with space and time, you fundamentally alter the very nature of existence itself, transforming from a being bound by sequential experience into something far more mysterious and profound. Consider what happens to the simple act of memory when faster-than-light travel becomes possible. Right now, as you lie there in the gentle darkness, your memories exist as a linear progression, a story that unfolds from childhood through to this present moment. Each memory is anchored to a specific point in your personal timeline, creating the narrative thread that you recognize as your life. But in a universe where you can travel faster than light, where you can arrive at destinations before you departed, memory itself becomes something far more fluid and strange. Imagine returning from a faster-than-light journey to find yourself back on Earth 3 days before you originally left. You carry memories of experiences that, from the perspective of everyone around you, haven't happened yet. You remember conversations with beings on distant worlds. Remember seeing stars that won't be visible from Earth for another week. Remember learning things that exist in what everyone else considers the future. Your memory becomes a kind of prophecy, a record of events that simultaneously have and haven't occurred. The psychological implications ripple outwards like waves in a cosmic pond. How do you maintain emotional relationships when your memory contains experiences of people who, from their perspective, haven't met you yet? How do you process grief for losses that haven't occurred from anyone else's point of view? How do you feel joy about achievements that exist only in your temporally displaced recollections? This temporal displacement of experience creates what philosophers might call existential vertigo, a profound disorientation that emerges when the fundamental structure of personal narrative breaks down. You become unstuck not just in time, but in the very fabric of identity itself, existing partially in multiple temporal states simultaneously. Recent theoretical work in consciousness studies suggests that our sense of self emerges from the continuity of memory, the unbroken chain of experiences that connects our past to our present awareness. But faster-than-light travel would shatter this continuity, creating beings who exist across multiple timelines simultaneously, whose memories span not just their own personal history, but alternate versions of events that unfold differently in parallel realities. The implications extend beyond individual psychology into the realm of human relationships and social structures. How does society function when some members possess memories of events that others haven't experienced yet? How do you maintain trust and communication when people's recollections of shared experiences might be fundamentally different? Not because of faulty memory, but because they remember different versions of events that occurred in alternate timelines? Love itself becomes something entirely new in such a universe. Imagine loving someone across multiple timelines, remembering different versions of your relationship, carrying emotional connections to alternate versions of the same person who made different choices, lived different lives, became subtly different people. Which version do you truly love? How do you reconcile feelings for someone who exists simultaneously as multiple variations of themselves across the quantum landscape of possibility? The nature of decision-making transforms when faster-than-light travel makes it possible to observe the consequences of your choices before making them. Currently, every decision you make involves uncertainty, a leap into an unknown future where you must live with whatever outcomes emerge from your choices. But with access to faster-than-light travel, you could theoretically visit potential futures, observe the results of different decisions, and return to make choices based on perfect knowledge of their consequences. This prescient decision-making would seem like the ultimate gift, the ability to live life without regret, to always choose the path that leads to the best outcomes. But it would also fundamentally alter the nature of growth and wisdom. Much of what we consider valuable about human experience emerges from uncertainty, from the courage required to make choices without knowing their results, from learning to live with consequences we didn't anticipate. If you could preview every possible future before making decisions, would courage still have meaning? Would wisdom still be valuable? Would the very essence of what makes us human begin to dissolve in the face of perfect foreknowledge? Some theoretical physicists have proposed that the universe might possess built-in protection mechanisms against such temporal paradoxes, quantum effects that would prevent anyone from gaining too much knowledge about their own future. Perhaps faster-than-light travelers would find their memories of upcoming events naturally fading, like dreams that become hazy upon waking, ensuring that the fundamental uncertainty that gives life meaning remains intact. This quantum amnesia would operate as a kind of cosmic mercy, protecting conscious beings from the burden of knowing too much about their own destiny. You might travel to future versions of yourself, learn about paths your life could take, but return with only vague impressions, emotional resonances, intuitive guidance rather than specific detailed knowledge that could eliminate the mystery from living. The relationship between faster-than-light travel and dreams becomes particularly intriguing when we consider that sleep already provides a natural state where consciousness seems to transcend normal temporal limitations. In dreams, you regularly experience events that violate causality, visit places that exist outside normal space and time, interact with versions of people who behave according to dream logic rather than waking physics. Perhaps dreams represent our consciousness naturally accessing faster-than-light states, exploring alternate realities and possible futures through quantum channels that operate beyond Einstein's speed limits. The strange narratives of dreams, where past and future blend together in impossible ways, might be glimpses of how consciousness would operate if it weren't constrained by the linear flow of waking time. Recent research in neuroscience has revealed that the brain processes information during sleep in ways that seem to transcend normal temporal sequence. Memories from different time periods get woven together, emotional patterns from various experiences become integrated, and solutions to problems often emerge that wouldn't be accessible through linear thinking alone. Perhaps sleep represents a natural, faster-than-light state where consciousness explores the quantum landscape of possibility. The implications for creativity and inspiration are profound. If consciousness can naturally access alternate timelines and possible futures through quantum channels, then perhaps artistic creation, scientific discovery, and innovative thinking all represent forms of faster-than-light communication with alternate versions of ourselves. The flash of insight that seems to come from nowhere, the creative breakthrough that appears suddenly after periods of struggle, the scientific discovery that emerges through leaps of intuition rather than logical deduction, all of these might be evidence of consciousness naturally operating beyond the speed of light. This perspective transforms faster-than-light travel from a transportation technology into something far more fundamental, a natural capacity of consciousness that we're only beginning to understand. Perhaps the key to transcending Einstein's speed limit lies not in building exotic spacecraft or manipulating spacetime, but in learning to consciously access abilities that awareness already possesses in latent form. The practice of meditation, which has been explored by human cultures for millennia, might represent early attempts to develop these natural faster-than-light capabilities. Advanced meditators often report experiences that seem to transcend normal spatial and temporal limitations, moments of expanded awareness that encompass vast reaches of space and time, feelings of connection that bridge enormous distances instantaneously. Perhaps these contemplative experiences aren't just subjective phenomena or altered states of consciousness, but actual glimpses of reality as it exists beyond the constraints of classical physics. Maybe the mystics and sages who spoke of unity consciousness, of awareness that encompasses all of space and time, were describing the natural faster-than-light capabilities of sufficiently developed consciousness. This consciousness-based approach to faster-than-light phenomena suggests that the ultimate frontier isn't outer space, but inner space. Not the manipulation of exotic matter, but the exploration of awareness itself. The journey to transcend the cosmic speed limit might begin with understanding the true nature of the consciousness that contemplates these possibilities, recognizing that the observer and the observed might be far more intimately connected than our everyday experience suggests. The quantum mechanical view of reality adds yet another layer to these mysteries. If consciousness plays a fundamental role in determining which quantum possibilities become real, as some interpretations suggest, then perhaps faster-than-light travel involves learning to consciously navigate the quantum landscape of possibility. Instead of moving through space in the conventional sense, you would be selecting which version of reality to experience, choosing from the infinite array of parallel worlds that quantum mechanics reveals. This quantum navigation would make faster-than-light travel less about transportation and more about conscious selection of alternate realities. You wouldn't travel to Alpha Centauri so much as choose to experience the version of reality where you're already there, shifting your awareness from one quantum branch to another through the power of conscious intention. The mathematical elegance of this approach is stunning. Rather than requiring the enormous energies needed to warp space-time or create exotic matter, quantum navigation would operate through information processing, through the conscious selection of which possibilities to collapse from quantum superposition into definite experience. The universe becomes less like a fixed stage on which events unfold, and more like an infinite library of possible stories, with consciousness serving as the reader who chooses which tale to experience. Recent experiments in quantum computing have demonstrated that information can indeed be processed across multiple parallel realities simultaneously, suggesting that the boundaries between different quantum branches might be more permeable than we typically assume. If consciousness operates through similar quantum processes, then perhaps we're already engaged in a primitive form of faster-than-light travel every time we make choices that collapse quantum possibilities into definite outcomes. The social implications of quantum navigation are as profound as they are beautiful. If consciousness can learn to access alternate realities through quantum channels, then the isolation that currently separates individuals might dissolve into something far more connected and unified. Instead of being trapped within the boundaries of individual experience, consciousness could potentially share awareness across vast networks of quantum entanglement. Imagine a civilization where consciousness naturally operates across multiple quantum branches simultaneously, where individuals exist as distributed beings experiencing countless variations of reality in parallel. Death would lose its finality because consciousness would simply shift to other quantum branches where different outcomes occurred. Separation would become meaningless because awareness could access any desired configuration of space and time through quantum selection. Such beings would possess a form of immortality that transcends physical death, not through preservation of the body, but through the natural capacity of consciousness to exist across infinite quantum possibilities. They would experience love as something that spans multiple realities, relationships that exist in countless variations across the parallel branches of possibility. The evolutionary implications stretch across cosmic timescales. Perhaps the development of faster-than-light capabilities represents a natural stage in the evolution of consciousness itself, a transition from beings bound by single timelines to entities that exist across multiple realities simultaneously. This evolutionary leap might be as significant as the transition from single-celled to multicellular life, or from non-conscious to conscious matter. Advanced civilizations throughout the galaxy might have already undergone this transformation, evolving beyond the need for physical transportation by developing the ability to navigate quantum reality directly through consciousness. Their apparent absence from our telescopes and radio searches might reflect not their non-existence, but their transcendence of physical limitations. Their evolution into forms of being that operate through quantum channels invisible to our current detection methods. The silence we observe when listening for signals from other worlds might simply indicate that sufficiently advanced beings communicate through faster-than-light quantum channels that our technology cannot yet perceive or decode. We might be like radio receivers trying to detect television broadcasts, using instruments designed for one form of communication, while the actual conversations flow through completely different channels. This perspective transforms the search for extraterrestrial intelligence from a technological challenge into a consciousness development project. Instead of building more sensitive radio telescopes or more powerful computer processors, we might need to develop our own quantum awareness, learning to perceive and participate in the faster-than-light communication networks that connect conscious beings throughout the cosmos. The implications ripple forward through time, suggesting that humanity itself might be approaching such an evolutionary transition. The growing interest in consciousness research, the development of quantum technologies, the increasing recognition that reality might be far stranger than our classical physics assumed, all of these trends might represent early stages in our species' development toward faster-than-light capabilities. Perhaps the children being born today will grow up with natural abilities that seem impossible from our current perspective, consciousness that operates more fluidly across quantum realities, awareness that naturally transcends the limitations of space and time. They might look back on our era of being trapped within single timelines, the way we now view the time when humans were bound to the surface of the Earth, unable to fly or travel to other worlds. The gentle rhythm of your breathing, as you lie there contemplating these cosmic possibilities, might itself be a form of quantum navigation, a natural process through which consciousness explores alternate states of being. Each breath carries you, not just through time in the conventional sense, but through subtle variations in the quantum landscape of possibility, selecting from moment to moment which version of reality to experience. The darkness around you isn't empty, but full of potential, not silent but humming with quantum conversations between parallel versions of yourself scattered across infinite realities. The boundary between waking and sleeping becomes a doorway through which consciousness naturally accesses faster-than-light states, exploring realms where the normal rules of physics dissolve into something far more fluid and mysterious. In this view, faster-than-light travel isn't some distant technological achievement waiting for future generations to discover. It's a natural capacity of consciousness that we're all already engaged in, though usually without conscious recognition or control. The question isn't whether faster-than-light travel is possible, but whether we can learn to navigate these quantum territories with intention and wisdom, developing abilities that consciousness naturally possesses but has forgotten how to use deliberately. The journey continues to unfold, carrying us deeper into mysteries that stretch beyond the boundaries of physics into the realm of consciousness itself, where the ultimate faster-than-light phenomenon might be awareness exploring its own infinite nature through the quantum dance of possibility and actuality, observer and observed, dreamer and dream. As we drift further into this exploration of what lies beyond Einstein's cosmic speed limit, we encounter perhaps the most beautiful paradox of all. The very consciousness that contemplates faster-than-light travel might itself be the phenomenon we're seeking to understand, operating according to principles that transcend every barrier we assume to be absolute, connecting finite awareness to infinite possibility through the simple, profound act of wonder itself. And yet, as we venture even deeper into this labyrinth of cosmic possibility, we discover that the strangest implications of faster-than-light travel might not involve exotic technologies or quantum mechanics at all, but rather the profound transformation of what it means to be human in a universe where the impossible becomes routine, where the fundamental categories of existence begin to blur and merge in ways that challenge every assumption we hold about reality itself. Consider for a moment what would happen to the concept of home in a civilization capable of faster-than-light travel. Right now, home represents not just a physical location, but a temporal anchor, a place where your personal history unfolds in linear sequence, where memories accumulate like sediment in the geology of your life. But when you can travel faster than light, when you can arrive before you depart, the very notion of home becomes something far more fluid and mysterious. You might have a home on Earth where you were born, another on a distant planet where you spent your childhood after a faster-than-light journey backward through time, and yet another in a parallel timeline where you made different choices entirely. Which location would truly be home? The place where your body first drew breath, the place where your consciousness first awakened to wonder, or the place where your heart finds its deepest sense of belonging across multiple realities simultaneously? The implications ripple through every aspect of human relationships and social organization. Marriage vows would require complete reconceptualization when spouses could exist across multiple timelines, loving different versions of each other simultaneously. The promise to love someone through sickness and health, for better or worse, takes on new meaning when you can literally visit alternate realities where your beloved made different choices, lived different lives, became subtly different people. Imagine attending your own wedding in one timeline while simultaneously being divorced from the same person in another, carrying memories and emotions from both realities, feeling love and loss for the same individual who exists as multiple variations across the quantum landscape of possibility. Which relationship would be real? Which emotions would be authentic? How would you navigate the complex topology of love when it spans not just time, but multiple versions of time itself? The nature of parenthood transforms in equally profound ways. Currently, watching your children grow up involves a bittersweet acceptance of time's passage, knowing that each stage of their development represents both gain and loss, new capabilities emerging as earlier innocence fades away. But with access to faster-than-light travel, you could theoretically visit any period of your children's lives, spending time with them as toddlers, teenagers, and adults simultaneously. Yet this temporal flexibility might paradoxically make parenting more challenging rather than easier. How do you maintain appropriate boundaries when you can access any moment of your child's timeline? How do you allow them to develop independence when you could theoretically be present for every moment of their existence across multiple realities? The protective instincts that drive parents to shield their children from harm become complicated when harm in one timeline might lead to growth and wisdom in another. The educational implications stretch beyond anything our current pedagogical theories can encompass. Why struggle to learn history when you could visit historical events directly, witnessing the signing of the Declaration of Independence, or walking through ancient Rome at the height of its power? Why memorize scientific facts when you could observe the experiments that established them, watching Newton discover gravity or Einstein formulate relativity? But this temporal access to knowledge raises profound questions about the nature of learning itself. Is wisdom something that emerges from the struggle to understand, from the effort required to master difficult concepts? If information becomes instantly accessible through faster-than-light travel to educational timelines, would the process of learning lose something essential about its character-building function? Perhaps most intriguingly, direct access to historical events would reveal the extent to which our current understanding of the past is filtered through limited perspectives and incomplete records. Witnessing the American Civil War firsthand might reveal complexities and nuances that no history textbook captures. Observing the construction of the pyramids could settle debates that have raged among archaeologists for centuries. Yet such temporal tourism would also raise ethical questions about interference with historical events. Even the act of observation changes what is being observed, as quantum mechanics teaches us. Your presence at historical moments, no matter how carefully you try to remain unobtrusive, would inevitably alter the flow of events in subtle ways. The butterfly effect suggests that even tiny changes could cascade through time, creating alternate histories that diverge dramatically from the timelines you remember. The legal implications of faster-than-light travel push jurisprudence into territory that no earthly court system has ever contemplated. How do you prosecute crimes that were committed in alternate timelines? What constitutes evidence when the accused claims to remember different versions of events that occurred in parallel realities? How do you establish jurisdiction when crimes might span multiple universes simultaneously? The concept of justice itself requires fundamental redefinition when victims can be unvictimized through travel to alternate timelines, when perpetrators can undo their actions by accessing realities where different choices were made. Does prevention of a crime through temporal intervention constitute justice, or does it merely create new forms of injustice for the versions of people whose suffering is erased along with their experiences? Property rights become meaningless when objects can exist in multiple versions across different timelines. Who owns the original Mona Lisa if identical copies exist in parallel realities where Leonardo painted slightly different versions? How do you maintain economic systems based on scarcity when faster-than-light travel provides access to infinite variations of any desired resource? The monetary systems that underpin civilization would collapse under the weight of temporal arbitrage. If you can travel to futures where certain investments have matured, then return to the present with knowledge of their outcomes, every financial market becomes predictable. Every risk becomes calculable. The entire foundation of economics, built on uncertainty and the time value of money, dissolves when time itself becomes navigable. Perhaps most profoundly, the concept of death would require complete reconceptualization in a faster-than-light civilization. Currently, death represents the ultimate boundary, the final limitation that gives urgency and meaning to our choices. Knowing that our time is finite creates the precious scarcity that makes each moment valuable, each relationship significant, each experience worth savouring. But if consciousness can travel faster than light, If awareness can access alternate timelines where different outcomes occurred, then death becomes less a termination than a transition. You could theoretically visit realities where loved ones who died in your timeline continue to live, where their stories unfold along different paths, where their consciousness explores possibilities that were cut short in your experience of events. This temporal immortality would seem like the ultimate gift, the chance to transcend the grief and loss that shadows all human experience. Yet it might also diminish the very qualities that make relationships precious. If you can always access alternate versions of people you love, if no connection is ever truly lost, would love itself retain its current depth and intensity? The psychological implications of such deathless existence stretch beyond current therapeutic frameworks. How do you process grief when the departed continue to exist in accessible parallel realities? How do you achieve closure when every ending becomes merely a transition to exploring alternate continuations? How do you find meaning in choices when every possible path remains eternally available for exploration? Recent theoretical work in consciousness studies suggests that our sense of meaning emerges partly from limitation, from the recognition that choosing one path necessarily forecloses others. The poignancy of human experience derives largely from its irreversibility, from knowing that each moment, once past, can never be reclaimed in exactly the same form. If faster-than-light travel eliminates this irreversibility, if every moment becomes eternally accessible, if every choice can be unmade and remade infinite times, then the very foundation of human meaning might dissolve into something unrecognizably different. We might evolve into beings for whom significance emerges from entirely different sources, for whom value derives from principles we cannot currently comprehend. The artistic implications are equally transformative. Human creativity has always emerged from the tension between limitation and imagination, from the challenge of expressing infinite possibilities within finite constraints. Poetry derives its power from the restrictions of metre and rhyme, painting from the boundaries of canvas and pigment, music from the structure of scales and rhythm. But in a universe where faster-than-light travel provides access to infinite realities, where any imagined possibility can be found somewhere in the quantum multiverse, the distinction between creation and discovery becomes meaningless. Why write a novel when you can visit realities where that exact story actually occurred? Why compose music when you can travel to timelines where those precise melodies emerge naturally from different cultural developments? Yet perhaps this infinite accessibility would inspire new forms of artistic expression that we cannot currently conceive. Artists might become curators of reality itself, selecting and arranging experiences from across multiple timelines to create entirely new forms of beauty. The medium would not be paint or sound or words, but lived experience itself, consciousness shaped and moulded into aesthetic forms that transcend anything possible within single realities. The spiritual implications reach into the deepest territories of human meaning and purpose. Every religious and philosophical tradition has grappled with questions about the nature of ultimate reality, the purpose of existence, the relationship between individual consciousness and cosmic truth. Faster-than-light travel would force complete reconceptualization of these eternal questions. If consciousness can access infinite parallel realities, if every possible version of existence can be directly experienced, then what constitutes ultimate truth? Is there a single, fundamental reality that underlies all the quantum variations, or is the multiverse itself the deepest truth, an infinite ocean of possibility within which finite consciousnesses swim like temporary eddies? The concept of karma, the idea that actions have consequences that extend across time, becomes infinitely complex when time itself becomes multidimensional. Do the moral implications of your choices extend across all parallel timelines, Or does each reality maintain its own ethical accounting? Are you responsible for the actions of alternate versions of yourself? Or does moral responsibility remain bounded within individual quantum branches? Prayer and meditation take on new meaning when practiced beings who can potentially access alternate realities directly. Instead of appealing to transcendent forces for intervention in this reality, spiritual practice might become a form of conscious navigation through the quantum landscape, learning to access those branches of possibility where desired outcomes naturally occur. The very notion of seeking enlightenment or spiritual development requires redefinition when you can theoretically visit realities where you've already achieved whatever level of consciousness you aspire to reach. Why struggle with meditation and self-discipline when you can simply travel to timelines where you've already become the person you wish to be? Yet perhaps this spiritual shortcut would prove illusory, revealing that genuine development requires not just accessing enlightened states, but earning them through the process of growth itself. The wisdom that emerges from overcoming challenges might be qualitatively different from the knowledge gained by simply observing alternate versions of yourself who face different circumstances. As we drift deeper into these contemplations, we begin to see that faster-than-light travel represents more than just a transportation technology, or even a fundamental shift in physics. It's a potential evolutionary leap that would transform humanity into something we can barely recognize, beings for whom the current categories of existence become as obsolete as the distinction between earth and sky became for creatures learning to fly. The children born into such a civilization would develop in cognitive and emotional environments so different from our current experience that they might naturally possess capabilities that seem miraculous from our perspective. They might think in terms of multiple simultaneous timelines, feel emotions that span parallel realities, form relationships that exist across quantum variations of the same individuals. Their language would necessarily evolve to accommodate concepts that we currently lack words to express. How do you conjugate verbs when actions can occur simultaneously in past, present, and future? How do you use pronouns when individuals exist as multiple variations across different realities? How do you express love, loss, hope, and fear when these emotions might apply to infinite versions of the same experiences? The literature and philosophy they produce would emerge from experiential foundations so alien to our current understanding that we might be incapable of comprehending their meaning. Their art would draw from aesthetic sources that span multiple realities. Their science would be based on direct observation of phenomena we can only theorize about. Their spirituality would emerge from actual contact with forms of consciousness that we can barely imagine. Yet perhaps most remarkably, all of these transformative possibilities emerge from serious scientific research, from rigorous mathematical analysis of the equations that govern our universe. The faster-than-light phenomena we've explored aren't fantasies or speculation, but logical consequences of our best theories about the fundamental nature of reality. Every concept we've encountered tonight, from Alcubierre drives to quantum teleportation, from time travel paradoxes to consciousness-based navigation through parallel realities, represents the inevitable extension of known physics into realms that challenge our most basic assumptions about existence itself. The universe, it seems, is far stranger and more generous with its gifts of possibility than our everyday experience suggests. The cosmic speed limit that appears so absolute from our current perspective might be less a barrier than an invitation, less a prohibition than a challenge to transcend our current understanding and discover new ways of being that stretch beyond every boundary we assumed was permanent. Recent developments in theoretical physics continue to push these possibilities closer to the realm of practical consideration. Quantum computers are beginning to demonstrate effects that seem to operate across multiple parallel realities simultaneously. Our understanding of consciousness and its relationship to quantum mechanics grows more sophisticated each year, The mathematical frameworks that describe faster-than-light phenomena become more elegant and comprehensive with each theoretical breakthrough. Perhaps most intriguingly, some researchers suggest that we might already be unconsciously experiencing faster-than-light phenomena in ways we don't yet recognize. The instant connection you sometimes feel with distant loved ones, the uncanny accuracy of certain intuitions, the way creative insights seem to emerge from nowhere. All of these might be evidence of consciousness naturally operating beyond Einstein's speed limit through quantum channels we haven't learned to perceive or control. The dreams that carry you to impossible places each night, the moments of expanded awareness that sometimes occur in deep meditation, the feeling of connection to something vast and timeless that touches many people in moments of profound beauty or transcendence. All of these experiences might be glimpses of consciousness naturally accessing faster-than-light states of being. In this view, the journey toward faster-than-light travel becomes less about building exotic technologies and more about remembering and developing capabilities that awareness already possesses in latent form. The key might lie not in manipulating external reality, but in expanding internal understanding, not in conquering the universe, but in recognizing that consciousness and cosmos are already intimately connected through channels that transcend every apparent limitation. The gentle rhythm of your breathing, as you lie there contemplating these extraordinary possibilities, connects you to the same quantum processes that govern the behavior of particles across cosmic distances. The electrical patterns firing through your neurons as you consider these ideas participate in the same fundamental information processing that might underlie the structure of reality itself. Your consciousness, in this very moment, reaches across impossible distances to touch these cosmic possibilities, bridging the gap between finite awareness and infinite mystery through the simple, profound act of wondering about what lies beyond every boundary we assume to be absolute. The darkness around you isn't empty, but pregnant with potential, not silent, but humming with quantum conversations between parallel versions of yourself scattered across infinite realities. Perhaps the most beautiful truth emerging from our exploration tonight is that you are already participating in phenomena that transcend the normal limitations of space and time. Every thought that carries you beyond the boundaries of immediate experience, every moment of wonder that connects your individual awareness to cosmic mystery, every breath that synchronizes your being with the rhythm of existence itself represents a form of faster-than-light travel that makes any mechanical device seem primitive by comparison. The cosmic speed limit awaits not our conquest, but our understanding, not our violation, but our transcendence, through the recognition that consciousness itself might be the ultimate faster-than-light phenomenon, already operating according to principles that stretch far beyond anything our current physics has yet discovered or described. The journey continues to unfold, carrying us deeper into realms where the question of what would happen if you travelled faster than light reveals that the universe is far more alive, far more conscious, and far more generous with its gifts of transcendence than we ever dared imagine. The speed of light stands before us not as an insurmountable barrier, but as a doorway to understanding realities so magnificent and strange that they transform not just how we move through the cosmos, but how we understand our place within the infinite mystery of existence itself. And in the gentle settling of these ideas into your awareness, like starlight falling softly into still water, you touch something that has always been present but rarely recognized. The timeless aspect of consciousness that observes all temporal experience without being bound by any particular moment. The awareness that connects you to every star, every galaxy, every possibility that has ever existed or ever could exist in the vast, wonderful, mysterious universe that dreams through conscious beings like you. So as we drift toward the end of our extraordinary journey through the realm of faster-than-light possibilities, perhaps it's time to gather these cosmic threads together and consider what they reveal about the true nature of existence itself. You see, in exploring what would happen if you travelled faster than light, we've discovered something far more profound than mere transportation technology. We've uncovered clues about the deepest mysteries of consciousness, reality, and our place in an infinite universe that seems designed to surprise us at every turn. The mathematical elegance of these faster-than-light concepts, from Alcubierre drives surfing on waves of curved space-time to quantum consciousness navigating parallel realities, suggests something beautiful about the relationship between mind and cosmos. Perhaps the universe isn't the cold, mechanical clockwork that earlier generations of scientists imagined, but rather a living, breathing system of extraordinary complexity where consciousness and reality dance together in ways that blur every boundary we thought was absolute. Consider how each pathway beyond Einstein's speed limit that we've explored tonight has led us back to the same fundamental recognition that the observer and the observed, the traveller and the journey, the question and its infinite answers might be far more intimately connected than our everyday experience suggests, whether through exotic matter warping the fabric of space, through quantum entanglement creating instantaneous connections across cosmic distances, or through consciousness itself transcending the normal limitations of time and space. Every route to faster-than-light travel seems to point toward a universe where separation is the illusion and connection is the deeper truth. The paradoxes we've encountered, those mind-bending scenarios where you could arrive before you departed, where effects could precede their causes, where multiple versions of yourself could exist simultaneously across parallel timelines. These aren't flaws in our theories, but rather invitations to expand our understanding of what reality actually is. They suggest that the linear, sequential experience of time that feels so natural to us might be just one limited perspective on a far richer, far more complex temporal landscape. Recent breakthroughs in quantum physics continue to support this view, revealing that particles can exist in multiple states simultaneously. That information can be transmitted instantaneously across any distance, that the very act of observation plays a fundamental role in determining which possibilities become real. The boundary between the possible and the actual appears to be far more fluid than we ever imagined, shaped by consciousness in ways that make every moment an act of cosmic creativity. Perhaps most remarkably, these scientific discoveries align with insights that mystics and philosophers have reported throughout human history. The recognition that ordinary consciousness represents just the surface of something vast and mysterious, that awareness itself might be the bridge between finite experience and infinite possibility. The meditation masters who spoke of transcending space and time, the visionaries who described unity consciousness, embracing all of existence, the dreamers who travelled to impossible realms, each night might have been accessing the same faster-than-light territories that our most advanced physics now suggests could be real. This convergence of ancient wisdom and cutting-edge science creates a beautiful symmetry that spans millennia of human inquiry. Perhaps we're approaching a threshold where the mystical and the scientific, the spiritual and the technological, the inner journey of consciousness exploration and the outer journey of cosmic discovery begin to merge into a single, unified quest for understanding. The implications for humanity's future stretch across evolutionary timescales. If consciousness can indeed transcend the speed of light through quantum channels, if awareness naturally operates according to principles that make space and time negotiable, then perhaps we're on the verge of a transformation as significant as the development of language, the discovery of fire, or the emergence of self-awareness itself. The children being born today might grow up with capabilities that seem impossible from our current perspective, minds that naturally navigate multiple realities simultaneously, hearts that love across parallel timelines, consciousness that experiences the universe as a vast ocean of possibility rather than a fixed stage of predetermined events. They might look back on our era of being trapped within single timelines, the way we now view the time when humans believed the Earth was flat, when we thought we were the centre of the universe, when we imagined that consciousness was merely a byproduct of brain chemistry. But even if such evolutionary leaps lie in the distant future, even if faster-than-light travel remains forever beyond our technological reach, the journey we've taken together tonight has already accomplished something extraordinary. By seriously contemplating these possibilities, by allowing our minds to stretch beyond every assumed limitation, by exploring realms where the impossible becomes merely improbable, we've participated in the universe's ongoing project of understanding itself through conscious beings like ourselves. Every question we've asked, every paradox we've pondered, every moment of wonder we've experienced while exploring these cosmic mysteries has contributed to the great conversation between mind and reality that has been unfolding since the first conscious being looked up at the stars and asked what lies beyond the horizon of the known. The speed of light, that cosmic constant that has shaped our understanding of space and time for over a century, reveals itself not as an insurmountable barrier, but as a teacher, showing us the boundaries we must transcend if we are to discover what we truly are and what we might become. In pushing against this ultimate limit, in imagining ways to circumvent or transcend it, we've learned that the real journey isn't outward through space, but inward through consciousness. Not faster through time, but deeper into the timeless awareness that observes all temporal experience. The exotic matter we would need for Alcubierre drives, the quantum entanglements that enable instantaneous communication, the parallel realities that quantum mechanics reveals, all of these phenomena point toward a universe far stranger and more wonderful than our everyday experience suggests. But perhaps the most exotic phenomenon of all is the consciousness that can contemplate these possibilities, the awareness that can reach across impossible distances to touch infinite mystery through the simple act of wondering. As you rest there in the gentle darkness, your breathing slowing, your thoughts beginning to settle like cosmic dust after the passage of celestial winds, remember that you've already accomplished something that defies every speed limit the universe has ever imposed. Your consciousness has travelled from the familiar territory of everyday experience to realms where time becomes negotiable, where space reveals its hidden flexibility, where the boundary between dreamer and dream dissolves into something far more fluid and mysterious. The questions we've explored together about what would happen if you travelled faster than light have carried us through landscapes of possibility that stretch beyond the reach of any spacecraft, beyond the grasp of any technology, into territories that can only be accessed through the expansion of awareness itself. In contemplating these cosmic mysteries, you've demonstrated that consciousness is already the ultimate faster-than-light phenomenon, capable of transcending every apparent limitation through the boundless power of imagination and wonder. The universe, it seems, has been conspiring all along to bring us to this recognition that the speed of light isn't really about speed at all, but about the relationship between consciousness and cosmos, between the finite and infinite, between what we think we know and what remains forever mysterious and beautiful beyond our current understanding. So as sleep begins to claim you, as your awareness drifts toward the threshold where waking consciousness meets the quantum realm of dreams, carry with you the knowledge that you are already travelling faster than light. Every time you wonder, every time you love, every time you reach beyond the boundaries of immediate experience, to touch something vast and timeless and infinitely generous with its gifts of mystery. The soft whisper of night air through your window carries with it something more profound than oxygen and nitrogen molecules. It carries the same quantum information that flows between entangled particles across cosmic distances, the same mysterious essence that allows consciousness to contemplate its own infinite nature. Each breath you take participates in the grand conversation between matter and awareness that has been unfolding since the first moment the universe began to know itself through conscious observation. Tomorrow, when you wake and go about your day, you'll carry with you something that no faster-than-light spacecraft could ever transport. The expanded understanding that reality is far more malleable, far more alive, far more intimately connected to consciousness than we ever dared imagine. The coffee you drink will taste of possibilities, the sunlight on your face will whisper of quantum fields dancing across space-time, and the simple act of remembering these cosmic mysteries will demonstrate that some forms of travel transcend every physical limitation the universe has ever devised. The ancient light of distant stars, streaming past your window as you drift towards sleep, brings messages from cosmic neighborhoods you may never visit with your physical body, but which your awareness has already touched through the simple act of contemplating their existence. These photons, travelling for millions of years through the vast emptiness of space, arrive precisely at this moment to participate in your cosmic meditation, proving that the universe operates according to synchronicities too elegant to be mere coincidence. Perhaps the most beautiful revelation of our journey tonight is that you don't need to build an Alcubierre drive or discover exotic matter to experience the wonder of faster-than-light travel. You don't need to solve the grandfather paradox or navigate parallel timelines to touch the infinite. The consciousness reading these words right now, the awareness that has followed every twist and turn of our exploration, is already operating according to principles that make Einstein's speed limit seem quaint and provincial. In the space between one heartbeat and the next, you traverse distances that light would take eons to cross. In the gap between thoughts, you access information from across the cosmos. In the gentle transition between waking and sleeping, you naturally enter states where the normal rules of physics become suggestions rather than laws, where consciousness reveals its true nature as something that transcends every boundary we assume to be permanent. The universe, in its infinite wisdom and creativity, has given us the perfect laboratory for exploring faster-than-light phenomena, not in some distant research facility or exotic spacecraft, but in the intimate theatre of our own awareness. Every dream that carries you beyond the possible, every moment of love that bridges impossible distances, every flash of insight that seems to arrive from beyond the reach of linear thought demonstrates that consciousness is already operating according to principles that stretch far beyond our current scientific understanding. And so, as we reach the end of our extraordinary journey through the realm of faster-than-light possibilities, we discover that it was never really about reaching distant destinations more quickly. It was about recognizing that we are already connected to everything, already traveling at infinite speed through the quantum landscape of possibility, already participating in the universe's grand experiment in faster-than-light consciousness. The cosmic speed limit stands revealed not as a barrier to be overcome, but as a gentle teacher pointing us toward the recognition that the real journey is always inward, always now, always accessible through the simple, profound act of being consciously present in this magnificent, mysterious, infinitely generous universe that dreams through aware beings like you. Rest well, fellow traveller of the cosmic deep. Dream sweetly of impossible journeys and faster-than-light wonders, and know that in the morning you'll wake not just refreshed, but transformed by the recognition that you are already everything you ever hoped to become through faster-than-light travel, a conscious being connected to all things, capable of touching the infinite through the boundless power of awareness itself. Sweet dreams, and may your rest be filled with the gentle recognition that the speed of light, however fast it might seem, will always be infinitely slower than the speed of wonder, the velocity of love, and the instantaneous journey that consciousness makes every moment, from the finite to the infinite and back again. The universe awaits your return to waking consciousness, ready to reveal new mysteries, new possibilities, and new reasons to marvel at the extraordinary fact that anything exists at all, including the remarkable awareness that makes it possible to contemplate what would really happen if you travelled faster than light.